Hello and welcome to Cometwatch with my name's Nicky Vetts and my co-host,
Neil Norman.
and we have two very special guests today. Our special guests, would you care to introduce yourselves?
Go, Terry,
Hello.
after you.
Oh, yeah. Hello. Terry Lovejoy here.
Nick Howes.
Welcome, Terry and Nick. Now, as usual, we're going to do a quick rundown of the comets that are visible for northern observers, and we always start with the latest discoveries. And as always, we are going to apologise because sometimes we do have problems pronouncing your name. We're starting at January 13th. The January 2015 edition of the Comet's Tale is published. And after you, Neil.
Yes, on January the 15th, discovery of 2015 A1 pan-stars was reported.
And on January the 16th, discovery of 2012 A2 pan-stars reported.
Yes, and January the 18th, Warashat Bloompod reports a Kreutz group comet in real-time C3 images.
On January 21st, Warchat Boomplod reports a non-group comet in real-time C3 images.
Yes, and on January the 22nd, Zhejian Zhu reports a Kreutz comet in real-time C3 images.
January 25th, Warchart Boomplod reports a Kreutz group comet in real-time C3 images.
And again on January the 25th, discovery of 2015 A3 pan-stars reported.
On January the 26th, Warchat Boomplod reports a Maya group comet in real-time C2 images.
On January the 28th, Richard Miles reports a significant outburst in 17p homes.
On January 23rd, Zaijian Zhu reports a Maya group comet in real-time C2 images.
Again on January the 31st, Simon Liao reports a Kreutz group comet in real-time C3 images.
February the 4th, discovery of 2015 B1 pan-stars reported, and that's also the day that this web page was updated. Now, current comet magnitudes. Now, this is from February the 1st, and the observable region is basically for UK observers. So, of course, Comet Lovejoy 2014 Q2 is at magnitude 5 and fading.
Hooray.
And it's at 90 degrees north to 35 degrees south. It's best in the evening, and the last visual observation was February 2015.
And I'd just like to add, Terry, if you're listening, it's still naked eye. I saw it last night myself. Anyway, back on to the next one. It's 15p Finley. The magnitude is 8.5 and it's fading, question mark. It's visible from 80 degrees north to 35 degrees south, visible in the evening, and last visual observation was in January.
Pan-STARRS 2012 K1, 11.5, fading. Now, it's 20 degrees north to 45 degrees south. It's an early evening comet, and it was last visually observed in December 2014.
Next up, we have the 2014 R1 Borisov, magnitude 12 and fading, 45 degrees north to 45 degrees south, visible in the morning, and last visual observation was in November 2014.
Siding Springs 2013 A1. Magnitude 12, steady, 75 degrees north to 5 degrees south. Again, it's a morning object, but last observed November 2014.
Next up is 2013 US 10 Catalina, magnitude 12. Trend is brightening, but unfortunately it's poor elongation at the moment.
29p, and I hate this one, Swashman Whackman, sorry if I got it wrong, thought to be at 13 magnitude. It varies 15 degrees north to 50 degrees south, early morning, last visually observed October 2014.
Yep, and also Alchemeden 2013 V5 is magnitude 12.5 and fading, 65 degrees north to 35 degrees south, visible in the morning, and last visually observed in October of last year.
Pan-STARRS 2012 F3, 13.5, question mark, steady, 25 degrees north to 20 south, early morning, last visually observed May 2014.
Next is 32p Comus Solar, 13.5 magnitude and fading, 75 degrees north to 40 degrees south, best visually in the morning, and was last visually observed in November of last year.
17p Holmes, 13.5, whoops, fading 90 degrees north to 15 degrees south. It's best in the early evening, and it's not yet observed from this area.
And lastly, we have Pan-STARRS 2014 Q1, magnitude 15, question mark. Trend is brightening, but unfortunately it's poor elongation and has not yet been observed.
Okay, we're going to recommend a good little website here. It's on the IAU Minor Planet Center site, and it's their possible comet confirmation page. So if you're really looking to find out what the latest comet is, this is a good place to go. And also always check out the BAA comet section for updates. Now, excuse me a second. Sorry about that. We have two very special guests with us this month, Terry Lovejoy and Nick Howes. And first, what we're going to do, we're going to have a little meander through the Comet family and an explanation of what the family name actually means, because a lot of people see this name as if you're a solar observer, you probably know about the sun grazers and stuff, but not a lot of people do. So, Terry, could you just take us through this, please?
Okay, well, the sun-grazing, well, the Kreutz sun-grazing group's probably the most populous known, I guess. There's something like 2,500 actual objects that have been identified, primarily in SOHO images, and most of them don't survive. So they become visible in solar coronagraphs up above the Earth's atmosphere. So generally they don't get seen from the Earth, and they come in close to the sun and usually disintegrate before they get to perihelion. Now, the actual history or lineage of the Kreutz sun-grazing group is quite interesting. I don't think anyone actually knows the true origin, but what we do know is that there are a lot of objects back in the earlier in the 1900s and into the 1800s, all very similar orbits, and also a object that was observed in 1106 by the Chinese and Europeans is almost certainly a Kreutz sun-grazing comet. So of the same type of family. There has been a couple of papers written about this recently and how they evolved over time, and it's believed to be due to thermal stress inside the nucleus of each of these comets. So what originally happened was a larger comet on a Kreutz sun-grazing orbit came in close to the sun. Thermal stresses caused it to fracture somewhat after perihelion. Interesting, there appears to be two different mechanisms for actual splitting. One is tidal forces near the sun, and the other one is from the flow of thermal or heat into the nucleus, which can cause the comet to fracture sometime after perihelion. So as a result, these things orbit in roughly the 500 to 1,000 year orbits or periods, and it appears they've been around a couple of times. So each time they come around, they split into more fragments or they disintegrate entirely. So we just happen to be lucky that we still have large enough fragments coming through even today that sometimes they can be seen from Earth. And obviously I was lucky enough to find one 3 or 4 years ago now, 2011 W3, which was the first since 1970. So I guess that gives you a little bit of an overview. of the Kreutz Comet group. I think, all up, there's probably been about a dozen or so members in the Kreutz group that have actually been seen from the ground, that have been bright enough to be seen from the ground. I guess they're also interesting from the point of view, when they're close to the sun, they can become extremely brilliant. The 1882 comet, for example, was described as being like watching a fourth magnitude star get occulted by the moon. That was kind of the comparison. So it was actually so bright you could see the comet as it touched the limb of the sun and went in front of it. So they really, to me, like, the fascination is they're the most brilliant comets ever recorded in history. And so to me, that's quite a special group of comets. But of course, there are other groups out there as well. But this is probably the most populous and probably the best studied one so far.
Now,
just to add, sorry, I was going to say, just to add though, Terry, these Kreutz comets, they generally, don't they? They favour the southern hemisphere because of the orbital inclination. It favours the southern hemisphere, doesn't it?
That's correct. So the inbound and outbound legs of the orbit are both south of the sun. And which is kind of unfortunate for you guys, although depending on what time of year, depends on whether they can be seen in the northern hemisphere. Like I believe March, April, that sort of time of year, if they come to perihelion, then you guys can see them, and also in September and October. Otherwise, they appear too far. If they arrive towards the middle of the year, they don't really get seen at all from the Earth. So to answer your question, the orbit spends most of its time well south of the sun. Yeah,
that's right. I mean, the actual aphelion point is in Canis Major, isn't it?
If you actually go far enough back, it's towards that direction.
Yeah.
If you go far enough away from perihelion, I think they come from a point in that area.
Yeah, because I was looking at W3, your comet. Had it survived on its outward journey, it would roughly just be above Sirius right now on its way out. So, but of course, it didn't survive, did it? It sort of like got blasted.
It got really, really faint. I think the last shots I got of it were in March, and you just see the faintest smudge. And I think somebody else who was in properly dark skies, I think, traced it as the faintest smudge into April. But even the early period when we could see it in the morning sky, it really just looked all tail. I mean, I saw that quite a few people were estimating the magnitude, but I it kind of just disappeared. The tail just stopped. It's kind of a weird comet to look at.
A headless comet.
When you read the 1887 descriptions, it's a dead ringer. The photos kind of show it, with a little bit of a head, but when you looked at it with a naked eye, it just looked like a tail, and then it just finished. Yeah. So, very odd thing to see.
Thank you, Terry. And now there's also Marsden and the Mayer groups too, isn't there?
That's correct. I think Soho, the work done with people discovering objects on Soho is sort of shown that those groups exist, and I believe, and I may be corrected here, but I believe there's a suggestion that they actually are part of a larger family, with 96P being the major member. to be quite honest, I haven't really kept up to speed with that, but I did hear some inklings that that 96P appeared to be one of the possibly the major member of a large complex of comets. And I think from memory, last time around, 96P actually threw off a couple of fragments as well. I think some people actually saw a couple of objects trailing 96P in the SOHO images, which is kind of interesting.
Now, because one of the things I've noticed that they seem to come as close as 0.025 AU. I think that's what happened with C1999J6, isn't it? But from what I can see, they do tend to be mostly comets that are observed by SOHO in the C2 FOV.
Yeah, I don't think they've ever been seen. I'm not aware of any observations from ground.
Yeah.
I think they're all too faint. Actually, one interesting thing, talking about 96P, if you look at the evolution of the orbit, that comet is steadily, perihelion is getting smaller and smaller. So it'll be interesting as it gets smaller, whether it starts to, start to fragment more significantly than what it has been. We'll see more of these objects appear basically before our eyes.
So definitely people should be looking at the SOHO images themselves as well, not just depending on ground-based observations with telescopes.
Yeah, absolutely. I think from what I've seen in the next 100 years, I think 96P, I think the orbit drops from 0.12 to 0.08 of an AU. So be very interesting Cometwatch.
Yeah, sorry, I was just going to say, the comet actually passes quite close to Earth, doesn't it? I think it's 2028, 0.3 astronomical units away off memory, I think it is. Comet Maschholz approaches us too, so doesn't it? And I think the next return is in October 2017, so it's not too far away to keep an eye out on, that one.
Yes, I think people should start really looking at the list of comets that are still out in the outer solar system that are slowly beginning to come back in, because and I don't know how you feel about on this subject, but the thing is, everybody is so hooked on some of the more shorter term stuff that they're not really looking outwards.
No.
Well, as I say, that's just my feeling. Everybody seems to be more interested in Jupiter group and stuff that's relatively short period. But very few people are actually making the time and effort to look further out into the solar system and looking at potentials. I'm just trying to think of a way to put this. It's early here.
I am.
I know you are, Nick.
Every day.
It's probably magnitude.
What Terry, and I'm going to put this to both of you. What magnitude limitation do you think people should start looking at for inbound comets at the moment?
16 to 18, I'd go.
Yeah.
In your average backyard telescope, that's, if you've got your C11 Hyperstar kind of rig with a CCD on, that's realistically, what most people are going to be hitting. Unless you've got access to bigger scopes and really good skies, it's not going to be much below that. And I think as Terry's proven, you constantly, I guess your detections are around about that kind of magnitude anyway, Terry. So
well, it's far from a dark sky here, but like even 18 is kind of, I think, pushing it even here. So I think you really need the dark sky. I'm kind of not really set up to go really, really deep, but I think the problem is limiting magnitude really to go out too far.
Field of view is the biggest problem we've got.
Yeah.
Yeah,
We can hit mag 23.5, but with a 10 arc minute field of view, it's like it's real
needle on a
needling.
haystack.
Yeah, it really is.
Yeah. So the actual question was whether we could look at known objects coming in from a far further distance. Was that the original question?
Um, it was. I think what I was trying to get at is should we be as amateur astronomers with access to even with the online scopes, should we be looking out further even for unknown stuff, or should we concentrate on predicted returns?
Well, I'd go 2 points on that one. One of the things we found really interesting was looking at comet recoveries, because some of the ones that are supposed to come in, due to obviously perturbations, they're not appearing where they should be. So being able to do comet recoveries at faint magnitudes where you've got a better handle on where it's going to be in the sky, then you can go really deep. You can do really long integrations and have a look for stuff there. Hunting for new stuff, I don't know, Terry's way better at this. So
Yeah, hunting for new stuff. So the problem again is coverage of the sky. So you can go to deeper magnitudes, but you cover much less sky, which is kind of what Nick was saying before. But with say with my setup, which is fairly wide field, I could elect to do longer exposures, but it would never cover enough sky to sort of make it worthwhile. So it's a bit of a balance between the exposure time and therefore the limiting magnitude and the amount of sky that you covered. Because there's always the risk if you focus too much on a small area of sky, something bright will just pass on through.
yeah.
Which is kind of what happens to a lot of the surveys, the professional surveys. There's been some interesting amateur discoveries sort of in the last 10 years or so, where a fairly bright comet is just threaded right through the survey areas, and it just happened to be that the professional surveys weren't looking in the right areas at the right times. But having said that, I think the really faint stuff is really the domain of the professional surveys. I see guys like myself just sort of picking up the pieces and then the gaps in between.
I think it's interesting though, because after Rob McNaught's kind of program was cancelled in the Southern Hemisphere, I think you've got a bit more of an open opportunity. I don't know if that's true, Terry, but that seemed to be one of the things that was interesting, like why CSIRO and government funding and NASA and all the other backing kind of got cold. That the opportunities are really there now, I think.
Well, the problem is, I'd agree in terms of like finding reasonably bright comets. Chances have got to increased, but then I'm not able to find the faint sort of stuff that Rob was finding. So they're just going to slip through. Although we have the LSST hopefully coming along.
Well, hopefully destroying any chance anyone's going to have of finding anything. It's going to, between LSST and the SKA, it's going to be like, oh my god, it's going to be a shooting gallery.
Which is kind of I don't think there's a problem with that. I'm quite happy for them to go and do that. Save me a lot of work, that's for sure.
I think the only thing is, though, with all these professional surveys, is that they're going to be it's getting the information out, whereas amateur astronomers such as ourselves, we see something, we confirm it over a period of time, we put in into the ME to the Minor Planet Center, and sometimes it'll probably be the best way because yes, they announce a possible discovery from Pan-STARRS, but I know they're also looking at other things like supernovae and stuff. So maybe we have a chance to. There's wriggle room because we have a chance to get in there fast. We can perhaps get the word out quicker because.
I think one area that we could look at more is looking at the NAEO CP page and the possible comet confirmation page, because as you said, a lot of the Sky surveys, what they'll post the data up there, but then they kind of won't do or have time for the follow-on. I mean, there was a classic one with Comet ISON where the two guys who found it put it on Neo CP, and our team then pointed Folks at it and went, "There's a great big coma there." This is not possibly a comet. This is a comet. And got the word out via social media literally within hours.
Well, as I say, definitely food for thought for everybody. And there's one final group we're going to ask you about, Terry. I'm going to just get back to my page, and it's the Mayer group.
Okay. What would you like to know about it?
Well, as I say, we do see the Mayer group crop up a lot on the Discoveries page, particularly on the BAA Comet page. So
they're very similar. They're very similar to the Marsden comets, aren't they? They were sort of like found around about 1996 as well, weren't they?
That's what I believe. I've heard the term the 96P complex being thrown about, and I believe they're part of that. Actually, I think they're probably the most populous, the Mayer comets. I'm just actually having a look at the page. It's a little bit out of date, and it's up around 120 Mayer objects that have been found, and then 34 for Marsden, and then the cracked comets around the 40 mark.
They're all very similar, aren't they, Terry? There's got to be a relation between, although they've got different names, they've got to be related very closely to, haven't they?
Yes.
There's very little between
really,
them.
Really quite interesting. There have been, actually even beyond that group, there have been a number of cases in recent years where we've had comets with almost identical orbits appear, a decade apart. I think the one that comes to mind is, and I'm stretching my memory here, but there was a comet in 1988, Comet Lilla, and there was another fragment another comet of almost identical orbits that appeared. It was actually around the time of Yakutaki. I think it was Comet Tabura. I think it was 1996. So 8 years apart, and the orbits are almost identical. So almost certainly from the same object originally. One that always interests me is the Kaya-Zhang, the 2002 comet, which was shown to be a periodic comet that appeared back in the 1600s. But there is another comet back in the 1500s, so back another century further back, that appears to have very, very similar orbital elements. And at one point, we weren't sure whether it was a return of the 1500s comet or the 1600s comet. So I wouldn't be surprised if we don't see more fragments of that comet in the future.
That's right. And of course, there's going back to the Kreutz ones. There's talk that maybe some brighter ones may be coming within the first couple of decades of the century, isn't it, Terry?
Yeah. The prediction was that they come in clusters. We had a cluster from 1963 through to 1970, and there's talk that 2011 W3 would be part of a returning cluster.
Yeah.
But I've had a look at some of the papers published, and I'm still not 100% sure we've been able to tie the ends up on the Kreutz group. Like, who knows? 2011 W3 was an interesting one in that the orbit was substantially different to any of the other Wright comets before. So, it may be a member of yet another subgroup of Kreutz comets. So the majority of them seem to follow the path of the 1843 Kreutz comet. So it seems like perhaps the largest component follows along that orbit, but there are these other subgroups that have come off in previous returns, and 2011 W3 being one of them, and maybe it's the first member of another group. So I guess we wait and see.
So it's definitely going to be worth paying attention to the SOHO images as well as visually observing and imaging as well then.
Yeah, it's well, the one I found, its light curve meant that it came up very, very fast. It brightened very fast, and some of them may not be visible very far before perihelion, so we may only know about them in SOHO images. Whereas, ironically, others, like 6 months after 11W3, there was another Kreutz comet that was substantially brighter, or so we thought, on the way in. It was actually showed up on the SWAN UV instrument on SOHO. So it was actually 2 or 3 magnitudes brighter than W3, and yet it didn't survive perihelion. So, I think probably goes to show there's probably a fair range of different compositions of the different fragments that are coming through. So, but whatever way, I think we need to keep a diligent eye out for them. And of course, I'll be doing my best down here in the Southern Hemisphere to try and look for another one. And I know there are other guys out there looking along the track at the moment.
And of course, the nice thing is, particularly for northern observers, if we can't get down to the Southern Hemisphere, we can always remote in to the Eye Telescope network and other remote instruments that are down in the south to have a look for ourselves as well. So definitely something for people to do. And really, SOHO images are so easy to get hold of, and they're released on a almost regular basis now. So get out there, get looking at these images. You never know, you might actually find one yourself, and if you can get the reporting quick enough, you may be lucky.
Yes.
So Neil, you're going to talk to us about Jupiter family.
Yes, the Jupiter family comets. There's an awful lot of those, I'm afraid. There's about 506 of them, up to and including 2014 X1, discovered by Leonid Elenin. These comets are believed to come from a scattered disk, I believe, which is an unstable area beyond Neptune, and there's around about 6 billion objects in there. So there's a lot of them out there that could possibly come in. They tend to have periods of under 20 years and very low inclinations as well, because they're perturbed by Jupiter, and they belong to that family because of Jupiter's immense gravitational pull, I'm afraid. Of course, the most famous one of those would have been Comet Shoemaker Levy 9, who actually crashed into the planet back in 1994. After being captured by Jupiter in, I think, maybe late 60s or early 70s, I believe.
Yes, I have to admit that was quite a spectacular period. And as I say, I suppose I was lucky. I was where I was working. I had a direct link to the States, and I could tap into live images at the time, and that was fun to watch. Of course, everybody says, "Why aren't you doing your job?" I said, "Well, I'm actually enjoying this. Have a look. This is a once in a lifetime
Exactly.
event." But yeah, it has happened twice. Anthony Weasley, with his famous impactor on Jupiter, we would really love to know if it was a comet or an asteroid. Thoughts? What are your thoughts on that, Terry?
Well, I think there was a second one, wasn't there? The following year, because I think they probably happened.
Yeah, Wes got two. Wes got two.
Brilliant.
Yeah. Yeah, interesting. I was talking to.
I mean, he got the Hubble switched on with the first one, didn't he?
Well, yeah.
Yeah, I was actually talking to him about this, and we're kind of thinking they probably happen a lot more frequently than first thought. And again, I think it's the fact that amateurs have who are able to follow the planets pretty much continuously. There have been advances with their techniques, and they can see and detect these or are starting to detect these impacts. And there's probably historic observations of Jupiter that have actually been of impactors and have never been recognised as so. So yeah, it's definitely another way of I suppose looking for comets to looking for impacts on Jupiter. So.
Jupiter's got a habit of, Jupiter can throw comets at us as well as kick them out of the solar system, can't it? I mean, the closest comet to ever come past the Earth was Comet Lexor, wasn't it? I think it's July the 1st, 1770. And that was thrown at us by Jupiter. And then another encounter basically almost threw it out of the solar system, didn't it?
Yeah. I thought it was quite an interesting coincidence that Rob McNaught found one of his last comets after his funding had been dropped, basically of 2013 A1, which was almost on a collision with Mars.
Yeah.
The first 3 days it was like, oh, this is going to be fun.
Well, yeah, because everybody was expecting, we're going to get a really spectacular
terraforming event.
Yeah, exactly. It's like, oh no, and of course everybody had to shift their space vehicles well out the way because we didn't know what was going to happen.
Bit of a problem for the landers.
Oh boy.
Those things can only drive at like half a mile an hour, so,
Yeah.
Good luck.
Yeah, I think one of them is actually static now, isn't it, because of wheel failure. You can almost imagine the camera fixed on this inbound comet getting larger and larger and saying, okay, bye-bye, rover.
Yeah. That would have been amazing. Unless you're Adam Steltzner, in which case you'd have been crying into your coffee every morning, but there you go.
But I think the thing is, what a lot of people forget is, we as amateur astronomers, we're in a totally unique situation in a lot of cases because we have the instruments and we have the time to follow up on something that the spaceborne instruments can't do, particularly the Hubble. The Hubble can't forever just be peering at Jupiter hoping for another Shoemaker-Levy 9. But we can be on there, and I was speaking to Dr. Kelly Fast, about the Weasley impact of the first one, and it was like they were scrambling, and the people were objecting. No, we can't use Hubble. We haven't tested all the kit yet, and it was a case of we don't care. We need to get.
You've got to test it on something. You can do all the calibration you want, but we've got a real event here.
Yeah. It was just like, it was hilarious, and I was actually listening every now and again. My MP3 player pulls up her parody of the Prince song, the 1999 Prince song, and I'm thinking, what would they do if a bunch of us suddenly were starting to scream at NASA? There's an event going on, and we need the Hubble on it. I think we'd get it now. I think we've got the credentials
I
confirmed.
think from the conferences I've been to, the professional community really do respect the likes of Christopher Go, Damien Peach, etc. These guys who are constantly imaging the planets, and you think, well, there's a lot of pretty picture stuff coming out of them. But as you say, now that you've got 60, 100 frame per second cameras able to pick up really very short period, very transient period kind of flash events on the upper cloud decks, this is probably one of the reasons why we are detecting more of them these days than we were historically, because photographic plates, you're just not going to get that stuff. You're really not going to get it at all. Even if it's a long exposure photographic image, in the old days, 2 or 3 seconds, transient event isn't going to really show up on that. But the flashes that you're seeing now on especially these low IR, very high IR sensitive cameras, they can get stuff. They can definitely. I mean, I wouldn't be surprised. It's interesting as well, looking at Damien and Chris and a few others' images of Uranus and others. There's going to be stuff going on there as well, and that to me is going to be the next one. Damien's now resolving quite happily cloud detail on Uranus. So don't be surprised if over the next, that'd be an amazing one to find as well. If next 20, 30 years we start to see amateurs picking up stuff like that.
I actually just on that. I was talking to Damien, or chatting to Damien, and saying, commenting that his images of Jupiter are better than Pioneer 10 or 11's images. I think that kind of just puts it into perspective.
I think the thing is we can adopt the technology much quicker than the space agencies can. But because they've got such a long lead time...
Lucky Imaging was... Yeah.
Because we can...
Lucky Imaging was a prime example of that,
But, yeah...
It's, the amateurs really picked up on that way before the professionals did.
I think that's the nice thing about being an amateur astronomer, isn't it? We do... I'm not being disrespectful to our professional colleagues, but more and more we're getting to be on the ball. Perhaps it's because of the fact we can dedicate ourselves to these long-term searches and imaging runs. Right.
We don't have funding proposals to write. We don't have grant proposals to get. We don't have scheduling time to budget for.
Exactly. It's we're giving our time gleefully because we want to do it for fun and for enjoyment. And I think we are actually we're reaping the rewards of such a position. Right, okay, now that's great. Now, Nick, I'm going to come to you next, and you're going to give us a quick talk about Martino, who we sadly lost recently.
Yes. Okay, for those of you who don't know, the team I work with at the Remazacco Observatory in Italy, so Ernesto Guido is my kind of long-term now comet hunting analysis data reduction partner, and we've been working alongside people like the Fox Telescope Project, the Liverpool Telescope in La Palma. We're working very closely with the Planetary Science Institute in America and Space Science Institute on some long-term comet morphology monitoring programs using large telescopes, so 2-meter f10 telescopes, and it's been really, really successful over the last few years. We've had a lot of interesting things happen, like fragmentation events. We detected a dust feature in Comet Ison that the Hubble also verified. Stuff like that, looking at the inner coma morphology. And initially, the three of us in the team was myself, Ernesto, and another Italian guy called Giovanni Sostro. Now, Giovanni passed away a few years ago. He had a heart attack, sadly, just before Christmas, and very sadly missed by us. So for about the next 6 months after he passed away, Ernesto and I just kind of worked as just a duo. And then the kind of workload was getting so much that we thought, well, we're going to need to boost up the team again. So we kind of had long chats and discussions, and Martino's name kept coming up as the person to really go for, because his analysis and the software he'd written in the past. For anyone who doesn't know, he was one of the co-authors of the software application AstroArt. And brilliant piece of software. It really is kind of one of the rivals to MaximDL, which in the amateur community is pretty much the prime application for kind of image processing acquisition that a lot of semi-pro stroke amateurs use for that kind of work. AstroArt's really, really good, very science-based. And Martino was a nuclear engineer, so a lot of physics background, a lot of mathematics background, a lot of algorithmic background. So he was using his software to basically develop algorithms for things like coma model processing, all sorts of different ways of really eking out as much detail as possible on the inner coma. So he developed the median coma model and all sorts of different plugins for AstroArt. Now, what was interesting, once we got Martino in, he's great. I mean, the sense of humour the guy had was amazing. His real diligence to professional science, seriously impressed everyone who met him. Everyone who knew him just said this guy is really, really diligent. For a non-professional astronomer, he's really on the ball. About 2 years ago at Space Fest in Tucson, I got approached by Beatrice Muller and Nalin Samrasina, who from the Planetary Science Institute, and they were looking at our work and saying, well, these guys, they may be amateurs, but they're doing some really good stuff. So they came to us and said, would you like to collaborate? And we were like, yeah. Anyway, so we used to have these kind of email rounds over the last couple of years, and Martino would kind of chip in with his thoughts and stuff. And it was interesting at first to see the PSI team's reaction to what he was doing, because they were obviously using very highly developed command line Linux-based utilities, looking at all sorts of different ways of it, again, doing this eking out of data, but using quite complex processes to do it. And Martino was coming back with, well, I've developed this plugin for AstroArt, and he was getting the same results. And more, every time these kind of emails would go around, it was obvious that Nalin and Beatrice were really beginning to appreciate that the amateurs were able to deliver the same kind of results that they were. So we were kind of working on, Comet ISON was a big one for us last year, and we were looking at this and looking at real sub-pixel optocenter kind of analysis, looking at, really getting the data right. And, the emails, as I said, they were bouncing backwards and forwards between Nalin in particular and Martino. He's saying, well, what if we do this? What if we do this? And it was really fantastic to see how the professional scientists were really beginning to respect him hugely. And I know when he passed away a few weeks ago, it was devastating. It was literally, we knew it was coming. Martino had stomach cancer for quite some time. We'd spoken to him about it all the time and made sure he was okay. And I mean, the beautiful thing he said to us in an email was, look, the data you guys are giving me is keeping me alive. Literally, it's keeping my will to be alive, strong. And that was just amazing, for him to say, literally what he was doing in terms of the comet observations was really emotional to get that. And then I spoke to him literally 3 days before he passed away and just said, how's it going? I said, we're hoping to get some more data from Liverpool. And he's like, I really think this is it. And you don't want to hear that. You really don't. And it just galls me that there's so many nasty people in this world that seem to live forever. And, the good guys seem to die young. But very, very sadly missed. And his Facebook page, I mean, the number of tributes he's had is just unbelievable. I mean, the guy's just so hugely respected and was loved by the comet community so much that, it's a real loss to not only amateur comet science, but professional comet science as well, I think.
Okay, great. Thank you, Nick. Yes, I didn't really have much to do with Martino, and I really came in and found out about him when you posted on the Cometwatch, when you and Neil posted about it. So it sounds like the type of chap I would love to have a chat with myself. Right, I'm going to wrap the show up, chaps, because we've actually gone for nearly 50 minutes on comets, and this has actually set a record for the show. So, well, the first show was about 17 to 20 minutes, and now we're up at nearly 50 minutes. So I want to thank you very much for joining us, Terry. It's really great to have you on the show. We're going to ask you back again soon, I'm sure. And Nick, thank you for joining us. So we're gonna say good day, good afternoon, good night now, because we don't know when the show's going out. It will be going out on astronomy.fm. We will try to get word out via Facebook exactly when the show airs. So we'll look forward to seeing everybody next month when we come back to do another show. So from me, it's good night.
And good night from me too.
And our guests.
Adios, dudes.
It reminds me of the two Ronnies.
Yeah,
I know.
Yeah.
Four standard candles.
Good night, everyone.
Take it easy.
Okay,
Bye.
good night.